All right. I hope everyone can hear me. So I'm Kari Koskinen, and I'm presenting you our use case. And I kind of take a bit of a liberty here to talk a bit about the use case aspects, not so much into technical details, but I try to bring a bit of what are the issues there in the actual industry, where you actually want to implement them. I do claim that we talk about smart cities, and I will cover this a bit, but you will find out that this is mostly about the traffic, which of course is a big part of the smart cities. And the problems in traffic management are pretty much the same as the other smart city initiatives in many cases. But I'm going to present our company and then about this whole landscape of smart cities and what are the issues there I think people should consider, which are not only technical aspects but something else. Then I give the motivation of why we want to use swarms, swarm intelligence, SmartEdge solutions and things like that in traffic. What's the reason, what are the problems we are aiming to solve, and so on. Then I'm going to present you the test area we have in Helsinki and some aspects of our exact use case. I think I'm going to keep that quite short because most of you have already heard it many times. Then I'm going to highlight some of the developments we have had so far. So I could take different things, but I actually picked these based on the discussions we have had in a couple of days here. So people were bringing up their interest, and I picked the ones that I find interesting and that are not covered by someone else already. So, like I said, Conveqs is a startup company. One could say that it's a spin-off from Aalto, but I did spin off from Aalto 10 years before I founded it in cooperation with some other folks. But we do have a very deep cooperation with the Aalto University. Our main focus is traffic modeling and traffic management. So that's where our expertise lies, and that's where we kind of think that our strong point is and where we distinguish ourselves from the other operators. Obviously, there is quite a bit of technology involved because we want to improve traffic with the new methods, new sensors, new computing capabilities, and so on. And this is where this aligns with the SmartEdge as well. So there are some technologies there. I'm not going to go through them in details, but it's basically something in edge, something in cloud, and something in between. So about traffic and smart city landscape, I wanted to highlight some aspects that are, well, I mean, a lot of people talk about smart cities and what kind of technologies you could bring into that. And a lot of things that are not mentioned much is that there are some specific things that make cities a bit different from, let's say, industry, not to mention academia. So there is intermingle of public and private, and by public and private I mean a bit different. It means a bit different things in different contexts. So in our case, we mean that, for example, street is a public space, whereas your home is a private space. And you might think that that's an ownership thing, but it's not, because you might have a public space that's owned by a private individual. In fact, in many cases in the cities, there is a building, and of course it's a private space what's inside the building, but the building has to maintain a street in front of it. And it's owned by that property, but it's public in a way that anyone can go to that street. So if you have a car, that's a private car, it's you basically determine the access to it. If you run a taxi service, it's a public service because anyone can access it, even if it's provided by private companies and operated by privately owned taxis. So these things make things difficult sometimes because there are kind of different rules in a public space and private space. And for example, privacy issues are different because you cannot control who comes to the public space. Anyone has a right to come there. Anyone has a right to not be followed, for example, in there. I'm going to come back to that point a bit later. Then there is another thing that makes it a different. It's the funding of the services. In many cases, but not always, a lot of things going on in the city, they are basically funded by the taxes. And let's say we make improvement of traffic management. It doesn't mean that we spend less taxes. Actually, the payment might be higher because we have to invest in the infrastructure of these solutions. And the beneficiary is the user of the road. So beneficiary might be a different one. And then, of course, there are private operators working in the city. They might have a taxi service. They might have some sort of whatever service. Pretty much everyone uses the traffic networks in the city. So there are different kind of operators, and they work in a different logic. And that's something that people coming from the industry academy never appreciate. That makes things sometimes very difficult and different. And I come back to that a bit later. What it causes then. It's also different organizational structures, not cities are the same, and this comes to the fact that if we make a smart city solution, it's traditionally very hard to move it from one city to another. So, for example, in our case, we have a nice test area, and it's all based on the fact that we have a good cooperation with City of Helsinki. We know the people there, we know how Helsinki operates. We even know what happens inside the city, which sometimes is important. But in practice, there is different kind of market structures. Sometimes things are operated by the city, sometimes they are privatized, sometimes they are tendering process, sometimes they are just bought outright. There is internal structures in the organization. For example, in Helsinki, there is 4 different municipalities that formulate Helsinki metropolitan area, and then they have a different company operating public transport and so on. So these kind of things make it difficult. If we organize in one way, we can find out that, okay, in the other city you cannot do the same thing because it's not owned by the city, even if you discuss with the city. Then important factor is the politics, and by politics I don't mean only the elected officials, although that's a part of it. They basically determine what are the goals of the, let's say, traffic network, but there are also internal politics. So there might be power blocks inside the cities, and if you don't know them, you might find out that your project is just not moving anywhere because someone is blocking it because of the political reason, because they want to control something, and there is power play there. And those are and it's not something that you could complain about it, but it's not something that's gonna go away because it's like internal part of the city. Then when we come to the traffic, and I'm gonna talk about traffic mostly for the rest of this. So this was kind of introduction because these are the things that consider traffic, but a lot of issues that I bring up, you can find parallels in other smart city things as well, because they basically face similar kind of, let's say, structures, similar kind of politics, similar kind of aspects. Also, there is a motivation of talking about traffic in smart cities because it's a very big part of any city operations. There is an interesting thing that we all spend 70 minutes approximately, a bit over an hour in traffic. And it's called Marchetti's constant because it has been constant since the dawn of time as far as we can know. So before people were even farming, it has been calculated that they spent about that much in traffic, moving around, trying to find food sources on average. They have even made an experiment that there are people who have been jailed, so they basically have nowhere to go as such because they are in a prison. And then they calculate how much those prisoners use to walking around inside the small space they have inside for going out, and approximately if they can choose, they will walk around about 70 minutes per day. So it's something internal in our mental thing. Nobody knows why, but that just seems to be constant. But that's a very important factor when you do something in the city. If you improve flow of the cars, let's say, what's not going to happen is that people are driving less. It means that they drive further away. And that's what happens in all the cities. So there are these kind of aspects that has to be considered. Also, I have to quote Adam Smith a bit, that the traffic is kind of in the center of everything, because Adam Smith basically claimed, and I think he's absolutely right, that all, let's say, wealth and all the improvement of human condition comes from division of labor. That's where all the efficiency comes, that we are not doing everything by ourselves, but we exchange in different ways, and then one specializes to other, and the other to the other, and then in combination we can produce more than we could if we did everything by ourselves. And that division of labor is limited by the extent of the market, and that extent of the market is the traffic. So it's in very core of all the goals that we want to achieve. So why SmartEdge solutions in traffic management? I guess the main point here is that current solutions are not very good. What we have in normal, let's say, traffic management is that it's something simple like clock driven, and even if it's vehicle actuated, it tends to be very isolated intersections that are controlled with very simple logic. Traffic light controllers you see on the streets, they really don't have any idea what the traffic is like. They just follow the logic. If this push button is pressed now, then next time around it will get green, and it will be exactly 15 seconds because that's pre-calculated. And if there are more cars coming, now when this is green, then it's extended by 3 seconds, and when there is no cars, then it's cut. It doesn't understand traffic, nor can it really share any information it has in the data system. In practice, there is reasons for this, which stem from those things that I previously said. There are certain, let's say, there are reasons why city officials tend to be conservative. And it's easy to understand if you think about it. And the reason for it is that if you are responsible for traffic lights, let's say in Helsinki, and then I come there and say that, hey, I have this nice solution. We have simulated this in the university, and we can say that you save 10% of the travel times for all the pedestrians, and so many lives per year, and whatever. A good solution. What he sees is that these guys come here, and if they succeed, which he doubts, nobody is going to notice, because these kind of improvements are widely spread to populations. Nobody understands that we saved one life. Everyone is, of course, happy that someone didn't die, but nobody understands that it's because of those initiatives we made. But there is potential downside. If we come there and we make a mistake, our system doesn't work, or we just have a bug in the code, or whatever happens, and there is accident or traffic chaos, that official is the one who is going to be blamed. So who put these crazy guys mess up our traffic? So he has a big downside but no upside. And that's why things are very, let's say, 70s. What actually then, this is kind of the current state of the game. But what happens at the same time is that there is a lot of new techniques coming about, which have been amply demonstrated in these days already in here, for example, both in terms of sensor technology, AI. We have a lot of new things coming about. And a lot of them are coming no matter what happens. The cars are going to be equipped with these kind of sensors. The cars are going to be more intelligent. potentially the cars could share this data with the city infrastructure if we make it possible. So at the same time, there is maybe more possibilities than ever, and we are still stuck in a rut in the city side. And what we try to do in this is to kind of start moving forward in this. Of course, there are a lot of challenges, and some of them I'm going to cover here, and some of them are tackled with the SmartEdge solutions partly. We are not claiming that we are solving all the problems, but a lot of, like, especially the technical issues are going to be accessed in this project. So, but it still remains. Market is difficult to penetrate for several reasons. I have some takes on that, how to do it, but still. So maybe I don't go much on this, but because of these reasons that city traffic management is pretty backward and possibilities are huge, and because everyone is in the traffic, like I said, about 70 minutes per day on average, it means that socioeconomic benefits are huge. I took those numbers from McKinsey report, which I believe it's a good guesstimate, I guess. But what I mean is that there are big potential in this area, like huge. But another takeaway you should take from this is that it should be noted that most of these benefits come to the road users. So it's so-called consumer surplus, and they don't pay for it. They just enjoy better life because they can move more safely or faster or whatever. So that makes it, from perspective of selling this, a bit difficult, because the city doesn't necessarily save any money by implementing this. It's their citizens who are winning. That's kind of the background and about the smart cities and about the traffic in cities and developing of new things. Then I move to a more practical side, which is our test case in Jätkäsaari. Some data here has already been shown from that, but basically what we have set up with good cooperation with City of Helsinki is 17 radars and cameras, and 7 traffic light controllers that we can have an access to. Main data sources are geocoordinate data from the radars, signal head statuses from the signal groups. We also have tram data from city system, and then road user detection from the cameras, which we hope to implement. There has been already good work in the TUB, for example, on that. What we also have, which I'm not going to go much this time, but we are building this digital twin, which would be then, what we mean, digital twin is a bit of a buzzword, so it means different to different people, but what we mean is that we would have a live view of how the traffic actually looks like right now. And then the traffic management could use that information. Other services as well could use it, or the road users and so on. We also have road V2X units installed. I'm going to come back to that in a moment. So this is the corridor we are talking about. There is the port there in the top, and then there is a motorway in the bottom right, and that's where all the trucks are coming from the port. It might come as a surprise to you, but Helsinki actually has the biggest passenger terminal in terms of passenger volume in the world. So it's not insignificant terminal, but that's passengers. Of course, the rate is totally a different thing, but the passengers, and it mostly comes from our connection to Estonia and to Stockholm, and there is a lot of people moving. So it's very important for the city, and it's very close to the city center as well. There are tram lines, there are walking and biking, and then there are trucks. So there is a lot of traffic problems there. I tried to show you, just to give you a bit of a flavor, how it looks like, both in terms of the radar. So these dots, this is now a video, but I can show you very similar live, that we get location of the vehicles detected by the radars, and then we can also see traffic lights there changing based on the what's happening in the traffic light controller. So this is the kind of data we get from there into our platform. In addition, we get the camera data, which we have been sharing with TUB and so on. So this is our kind of data collection platform, and that's quite a big part of the what we aim to do here. In addition to this, this is kind of the Conveqs side. Then there is the Aalto side, and Aalto has nice set of instrumented vehicles. They are basically not built for us or for this project, but they just have them for different kind of research purposes. Mainly they are focused in two things. They want to measure what's happening in the car, so they are researching automated driving and functions like that, and what's happening outside of the car, meaning they want to measure the traffic. They have LiDARs, cameras, GPS units, and quite a bit of computing capabilities. I'm not going to go into these details, but some of the things we are using in SmartEdge, and we have shared the data with Dang's team, for example, quite a bit already. We are also adding new hardware for this purpose. So namely, onboard units for V2X is something that we are putting there that didn't exist. This is, well, just to get something more interesting in here, this is how the cars look like. You see the LiDAR in top. There is the computing unit, and then there is one camera. We are putting stereo cameras there as well, and so on. So there is going to be some improvements done. But it's quite flexible because university has full access to those cars, and they are part of the consortium, although they are not presenting here today, but they are cooperating with us. So it's easy to get things. We are for example putting these Orin units inside the vehicles so that the TUB guys can test their system in the vehicles. These are the V2X devices, and this is maybe the latest developments. I'm going to show a couple of things that we did with them, but we got them for this project, and last year they were experimenting in the lab and figuring out what are these things anyway. There is basically roadside unit in the top right. From your perspective, that's the kind of thing you put on the road, and then there is onboard unit, which looks like basically what kind of modem you could have at home, but that's for the car. I think technically they are very similar, but the idea is that they use this same bandwidths or close by than Wi-Fi, and they have some standard communication protocols available, and we aim to use that in SmartEdge. Why we use that? The reason is not only that we couldn't do stuff we do with let's say 5G or 4G networks, but we are also interested in getting this data from the vehicles. Then in the longer term it has to happen from in the industry, and we are expecting, maybe hoping, that these kind of capabilities are becoming more or less standard in the cars in the future, which might or might not happen. That's the other side of the story, that there is a big industries involved and they have their own incentives and so on. But it has been moving along quite nicely lately, so we are hopeful that it will appear and we might be able to employ this technique in the future. This is kind of overreaching picture of our holistic idea, which I more or less explained. So we get different kind of data types. We create digital twin, then we employ SmartEdge toolchain, and then we make it possible to do the traffic management side. I'm going to talk about the traffic management side shortly, because we are developing an open source traffic light controller which might interest you guys, even though it's not directly, well, it's going to be used in SmartEdge, but it's not directly a SmartEdge project. But we are doing that as well. So and it's a kind of big part in our solution of opening this box of not moving anywhere like the cities have been doing so far. The use case is like this, but I think I'm gonna maybe skip most of it. The basic thing for those who haven't seen this already is that we chose a very simple thing that we can do to enhance traffic controller. And we chose this option zone management, which is single function that a lot of traffic light controllers do. We try to improve that with two-way communications between the vehicles and the infrastructure. So when the traffic light is green and you are approaching it, and the traffic light controller decides that now it's a good time to end this green, there is kind of three different possibilities from the driver's perspective. The first one is that you are in very close to the intersection, almost crossing the stop line. And when it goes amber or the green is ending, there is no way you can stop, so you will go through. It's like 100% of the cars are going to go through, and that's what they should do. That's why we have the amber light there, that it's still legal to go through, and that's what we expect them to do. If you are very far, there is no way you can pass that on green, so you will stop, and 100% will stop. But in between, in some cases, there is this area of what we call option zone, and that's area where you can decide that you go or you can decide you stop. And okay, decision by driver, but there might be case that the car in front decides to stop and car behind slams the gas because he thinks he's gonna go, and then you have a collision. So it's a potential safety hazard, and there are ways to work with that. In our use case, there is actually detector-based solutions to cope with it. You can put the detector here, and you can make a single function that that detector should not detect any vehicles, or at least not two vehicles in, let's say, 5 seconds that we estimate these to clear out, and then only after that you stop it. In our case, we do two things. We try to get data from these cars about what the option zone looks like. Is it empty? And then we try to, let's say, send a hint to the vehicles. We are not controlling the vehicles at this stage, but we are sending message back that, hey, could you slow down so we can make a gap here? Of course, in this case, it's a proof of concept that we can do it, but you might imagine that in the future you have automated or semi-automated cars that already follow the car in front, and if the infrastructure tells that can you make a gap, they could slow down and the car in front, then it would be ending safely, the green. So that's the idea. And it's of course just proof of concept that we can have this two-way communication, that the cars can actually join our swarm, which is in a sense these sensors and the controllers in the roadside. So that's the thing. Then some of the things we have done. This is the first V2X experiments we did this summer, and we have actually there the unit. That's the same unit I showed you a picture before. We installed it last spring, and this is one of the Altos cars with the LiDAR, and we have a V2X unit there inside. And what we did here was that we combined LiDAR and LiDAR processing and V2X. You see some of the results here. So first of all, these dots are marking where the car was detected. So every second it was sending its own location. And then it had a LiDAR, and they were using some simple out-of-the-box AI model to determine where are vehicles in the LiDAR data. So you get this point cloud, and then you determine that's a car, okay? Then they calculated that car's physical location. And these stars here are every second determining that there is vehicle here, there is vehicle there. And all of this was then the detection of the vehicles, and the movement of the car was relayed via V2X, and it came to our system, and then we drew it here. So it was very simple proof of concept that the vehicle can determine what's happening around it, and it can send it via V2X technology to our cloud, and then we can draw it on the map. We have a master's thesis. If you are interested, I can share the link to it if you want to read what we did. It's a very simple experiment, but it's the first step. We couldn't yet track the vehicles. We would hope to get pedestrians as well and so on. So there is a lot of room to improve. Also, this AI function was relatively slow, so we could only determine them once per second, and we couldn't track the vehicle. And these are kind of things that people are working with in SmartEdge, as we have learned earlier. So that's one thing. Then there is an open controller, which I want to advertise a bit. Like I said, traffic management hasn't moved much since the 70s, and the main reason is that the companies who are providing the traffic light controllers, they basically have a proprietary controller software, and they have implemented all the functions that are in there and the protocols, and they try to open them, but they are not very open. So we have found it very hard in practice to get any data from traffic light controllers, not to control the traffic light. And what we aim to do, because of the market, like I explained, we want to do it such a way that we produce basically a replacement of that in open source, that anyone can come to the market and implement all the same functionalities that they are now implementing. And in addition, it will have interfaces for anyone to put their own traffic management there. The idea is that we will cover the safety critical parts, and then we are not doing hardware at this point, but we could do hardware as well. And then if you have, like I know that if you go to libraries of universities, you will find dozens and dozens of papers of people explaining that we have improved traffic light control with using fuzzy logic or AI or deep learning or mathematical modeling. There is everything has been tried, and everything has been proved to work better than what we have, but only on simulation. And we want to open it up that this kind of work could actually be implemented in actual traffic. And for that, we need an open source traffic light controller. Trust me, I have tried all the other ways before. But it's not actually that complicated, because the traffic light controllers, they are not like a very sophisticated pieces of software. We are putting that out quite soon, so we hope to get some traction. We will see how it goes. But anyway, that's what we are doing. And this is going to be used, by the way, in SmartEdge in demonstration as well. We have controlled traffic with this already. It doesn't have all the functionalities needed to be replacement yet, but it will be soon enough. Then there is the other thing which we have discussed quite a bit here, and that's privacy and open data. There is maybe something that people don't think about much. Certainly it seems to come as a surprise to a lot of people I've been talking to, is that what is the reason for these privacy concerns? Everyone knows that there is GDPR legislation which you have to adhere to, and it causes a lot of pain to a lot of research as well. But the main reason why there is the AI technology, basically. In the old days, the cameras were not the problem, nor were they solution. But they weren't the problem, because you can place cameras there and record what happens, and following any one person wasn't the problem, because you can always put a guy watching the video stream and follow the guy around. But you can as well put the guy following him around in the street. So it was very, let's say, resource intensive to start following people. And that's why it wasn't such a problem, because nobody puts those resources in. For example, police can have a legal reason to start following me if I'm doing drug dealing or whatever illegal activities. But they will actually have to put a lot of resources to stop following me. But now when the AI is around, you can just put an AI and it can follow anyone, anywhere, everyone, everywhere, very cheaply. And that's totally a different kind of society then, because then it makes it possible to, like, law-obeying citizens, generally speaking, can be followed, and that's not what we want. That's why we have the legislation. So at the same time, AI brings these possibilities for us, for improving traffic, for example, but it also causes those problems. And it should be acknowledged that it's not only cameras that we are talking about. Pretty much all the sources of traffic, all the sources of data we have nowadays might become a problem in the future. And it's something we have to consider, and it's something we have to resolve if we want to get these nice technologies into the field. It's not an optional to not solve that and just say that, okay, we don't have to care about it. It's the law, and it's what we want as a society as well. Certainly I do. Because of that, we found out that we had a lot of issues with the camera data we have in Jätkäsaari. And it turns out that the city didn't even know what to do about it. GDPR was a relatively new thing. They didn't have any way of handling. So what's the deal here? What data can be shared with whom? What is the process here? And we actually made a process with the city about how to share it. So we now can do it. The current setting is that all the data is owned by the city. So they decide how to share it. I cannot decide that. Even if I want to share it with someone, I cannot do it. I have to apply it from the city. But we do have a process for that. So we have given access now to TUB and Aalto University. And what we need to be done there is that you have to define what privacy policy Aalto and the university is following to make sure that it doesn't go to the outside. It has to be, there is a form you fill for the city, and they have a process who accepts it, and then you get some stamp of approval, then you get an access. One thing is that you have to have legal reason for this. In our case, it's simple because there is legal reason for this kind of privacy sensitive data is research. That's one reason. You have to state it there. You might have other reasons, because it doesn't mean that if it's a privacy sensitive, you might have legal reasons to do it. For example, safety, or safety of the traffic, or traffic improvement, and those are possibly reasons, or whatever, but it has to be stated. We also have, and that's kind of an interesting, and it might be of interest to you as well, I think Dang was the primus motor in this, because he wanted to open this data set that we've been collecting, so that first of all people can judge if the things they have worked with, and they say that we have this algorithm and these improvements, you can actually see that if you can compare it with the data, you can ensure that that's actually true. And then the other side, that other people could use that to train their AI models and so on. And we do have an interesting data set. There is other data types than cameras, but cameras obviously are the most problematic from the privacy perspective. And what we aim to do is to apply an algorithm to falsify the faces and license plates and things like that, and make sure that it adheres to the privacy standards, that it's private enough so that you cannot follow individual people there, and then get approval, and then we want to basically define the process, how you do it, and then write it down, how you do it, what are the steps you need to do, and hopefully that could be useful for other researchers in the future as well. So that's the kind of interesting thing that we have going on as well.